Hi, welcome to Lesson 6 of CSEC Chemistry at Edu Solutions Institute. So today's lesson will be focusing on chemical bonding or bonding. Alright, last week we looked at the structure of the periodic table and why the periodic table exists, why atoms or elements are placed in that specific sequence. We look at the groups, the periods. Alright, so today we're going to look at bonding, because we know that atoms will undergo bonding. That's why we have water, that's why we have table salt. Now, why do they undergo bonding? That's because they are unstable. Unstable means they don't have their valence shell filled. So metals from last class, you know, metals are atoms that their last shell only has 1 to 3 electrons. That means they need a minimum of 5 and a maximum of 7 to fill their entire shell. What would they do, right? And for non-metals, they have ranging from 5 to 8 on their outer shell. So that means except for group 18 that's already full, all the other non-metals need to actually get up to 8 electrons. So they are unstable. That means they're going to be reactive. They're going to want to join with something else and get what they need, right? Now, the type of bonding is dependent on the elements that are present to undergo the bonding. We have 3 types of bonding. It could be ionic bonding, covalent bonding, or metallic bonding. So we're going to look at each individually to see how do we know which type of bonding is present and how do we do that bonding. So firstly is the ionic bonding. And ionic bonding, we need two types of elements. It's between metals and non-metals, right? Now, the reason why it's called an ionic bonding is because it requires forming ions. And ions are charged particles, or charged atoms. And the reason why they are charged is because the metal lose electrons and the non-metals gain electrons. So because metals lose electrons, they now have a charge. In non-metals gain electrons, they now have a specific charge as well. So ionic bonding, you have to have a metal and you have to have a non-metal. What happens when you have those two? The electrons transfer from metals to non-metals. Because remember, ions, metals have to give, non-metals have to get. So we're giving metals, giving the electrons, non-metals are receiving those electrons. Now, let's look at an example. Let's look at sodium and chlorine. So how do we know? I normally first thing would like to identify what's our valence electron. Right? So valence electron, sodium has 1 on its outer shell, chlorine has 7. How do we know? From our periodic table, sodium is in group 1, chlorine is in group 70, so it has 7 on the outer shell. Now, so we know that if sodium has 1 on the outer shell, it's easy to lose that 1 than to gain 7. So therefore, sodium is our metal that will lose 1. Right? And then chlorine is our non-metal. It's very close to 8. So what it's going to do, it's going to gain 1 because it just needs 1 to become 8. So in the structural arrangement, what we will do is to put sodium here. With sodium is 11, so 11 protons and 12 neutrons. And what we're going to do is that we're going to just draw the valence shell to put the 1 electrons out there. And then it's going to send that electron over to chlorine, that is 17 in atomic number, and it's 35.5 in mass number. So it's going to be 18.5 neutrons. All right, and then its outer shell, instead of using X, we're going to use dots. So we can distinguish between both of them. Right? And then we have the one there that it needs. So what we do is that we take the one from our sodium that needs to go over onto our chlorine. So now what we now have is that there's an atom of sodium that is going to be positively charged, and it's one positive because it only gave away one, and that will be attracted to chlorine, that now has 8 on its full shell that received 1, so it's a negative 1 charge. So now because these two have opposite charges, they're going to be attracted to each other and they become a bond. Right? So because this gives away its 1 electron to this that needs 1 electron, then they now stick together because they now are two ions that have charges that they can now attract to each other. Right? Let's look at our next one. So let's look at magnesium, and let's go with chlorine again.
So we know magnesium is a metal and chlorine is a non-metal. So magnesium will lose 2 electrons and chlorine we know will gain 1. From here we'll draw magnesium. On its outer shell we have 2 electrons, right? And then we draw chlorine, which has 17 protons, 18.5 neutrons, and on its outer shell we will draw 7 electrons, each having dots. So the 1 electron will be transferred to chlorine, but magnesium is still on balance because it has 1 more electron to be given off. So instead of using 1 chlorine, we now will introduce a second chlorine atom to gain that 1 free electron that magnesium has. So we will draw another atom of chlorine, 17 protons, 18.5 neutrons, with 7 electrons on its outer shell, and then we transfer that free electron from magnesium over to chlorine. So now we have the 2 electrons from magnesium being transferred over to the chlorine atoms. Now that will give us a stable form of magnesium being 2 plus charge. 2 plus because it gave away the 2 electrons that it had. And it's plus because it is a metal and it gives away. And then we have chlorine, which now has a valence shell of 8 electrons because we donated an electron from the magnesium to the chlorine. And that's a negative charge because it was 1 electron received. Because we used 2 chlorines, we had to draw 2 ions of chlorine to represent that it was 2 chlorine involved in this bonding. So the compound for the sodium and chlorine was that we use 1 sodium and 1 chlorine. So hence we get NaCl, where it represents 1Na and 1Cl. Now for magnesium, it is 1 magnesium and 2 chlorine. So therefore it is MgCl, and we put a 2 there to represent that we use two chlorine atoms for this bonding. So therefore we get MgCl2. Now we don't use a 1 if it's 1 because it doesn't represent well in your representation. So we normally just leave it as Na or Mg without using the 1. Right? Now these these compounds, sorry, are have a special name. How do we name it? We use the metal first, followed by the non-metal, replacing the INE with ide. So for the first one, it's sodium chloride, and the second one would be magnesium chloride. And that's the end of the ionic bonding. Let's move on now to our covalent bonding. So ionic was transfer of electrons. Now with covalent bonding, this is the sharing of electrons. Now, which type of atoms experience covalent bond? These are only involved with non-metal atoms. So non-metal elements are the ones that will share electrons because they normally tend to want to receive electrons. So hence, if they both are receiving, then they can easily share electrons to become stable. And remember, stable means they will have 8 electrons on their outer shell, except for helium, that will have 2. Now we're going to start an example with sulfur and chlorine. So the first thing to identify with sulfur and chlorine is that sulfur is 1632 in mass, chlorine is 17 and 35.5 in mass. Now, it's important to also realize that sulfur has 6 on its outer shell. So that means it will need 2 electrons to become 8. Chlorine has 7 on its outer shell, so that means it will require 1 electron to become 8. So with that, knowing that we need 2 for sulfur, 1 for chlorine, then that means we'll choose the one that needs the least amount. So we use chlorine to guide us in telling us that each atom will share 1 electron each. So we will go start here with sulfur. We put sulfur, going to put our 6 electrons on its outer shell, right? And then we will start drawing our chlorine. Now, to show the representation of sharing, on its outer shell, we will overlap the 2 outer shell atoms. So now we overlap chlorine with sulfur. We draw our 7 dots to represent the 7 electrons of chlorine, and then it overlaps with that 1 electron from the sulfur atom. So therefore, now that overlapping represents, if we block out the sulfur, we now see that we will have 8 electrons counting with that X plus the 7 dots from chlorine. We now have chlorine having 8 electrons on its outer shell. If we block out the chlorine, look at the sulfur. Sulfur still needs 1 electron. Where is that 1 electron coming from? From an extra chlorine atom that will now share 1 electron with that free electron from sulfur. So now if we block out any atom, the sulfur or 2 chlorines, then we'll now realize that sulfur has 8 electrons on its outer shell, as well as for the 2 chlorines, they also will have 8 electrons on the outer shell. And that leads us into the formula where we use 1 sulfur and also we use 2 chlorine atoms. So therefore we get SCl2 because 2 chlorines was used to bond with 1 sulfur. And the formula for this compound would be sulfur chloride. right? Now, some books will see dichloride, and that's because it's just signifying that it was two chlorine atoms that was used within this bonding. So you can represent it with the di, but most times we will not include the di, but it will not be wrong if you have di in your name. So again, you have to realize how much each atom needs in order to become heat, and from that you select the one that has the lowest amount that it requires to become an heat. And that tells us how much electrons each of the atoms will share in order for it to become balanced, and that means for it to get 8 electrons on its outer shell. Now look at the final type of bonding, which is called metallic bonding. By the name suggests, these deal with metals, right? So metals in its nature are just regular atoms. For us to express these atoms in a physical state, then they have to be bonded with each other of the same metallic element. So example, sodium. Sodium is a powder, right? So therefore it has a structural representation. Now in that sulfur powder, it will be multiple millions of atoms of sulfur. And how do we get it to be in that form is that each sulfur will be bonded with your neighboring sulfur atoms to create that structure that we know is called the sulfur powder or the sulfur metal. So therefore, all these metals that exist will bond with themselves to give you a physical structure. Now, each structure is quite different based on the type of metal that is being used to to bond with each other, right? How does this one work? This one works because they are the same type of atoms, so there is an attraction between the same similar atoms, and hence that strong attraction is what keeps the atom firmly together and give you that structural arrangement. Now for some structures based on the syllabus, it's required that you know at least one or two structure of how it's drawn. Alright. So remember each atom has its own structural arrangement. So they have a different shape. Alright. So for one sulfur chloride, sodium chloride is also one that can be expressed in a structural formula, or the sulfur atom in its metallic form could also be used to show the arrangement of these atoms. So that's it for us today. I hope you enjoyed, and I'll see you next week.